Stomach cancer is not a sudden event, but the result of a decades-long accumulation of oxidative stress and oral bacteria colonizing wounded tissue, creating a self-perpetuating cycle of damage that overwhelms the body's repair mechanisms.
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom.
Today we are initiating a deep dive into the gastric environment, bypassing the standard late-stage diagnostic models. We need to look at the cellular mechanics decades before a severe pathology is ever detected. The literature we're analyzing presents a pretty harrowing reality about this silent progression.
It remains the fourth leading cause of death in its category globally, with nearly 770,000 lives lost in 2020 alone. And that mortality rate is driven almost entirely by the stealth of the pathology.
When we look at the clinical presentation, symptoms like indigestion, anemia, unexplained weight loss, these are routinely dismissed as minor gastrointestinal disturbances. Biologically speaking, those symptoms are the final alarm bells of a system that has already completely collapsed.
The research mandates a shift away from macroscopic symptoms down to microscopic precursors, specifically focusing on the cellular identity crisis that occurs long before any malignancy forms.
We're talking about intestinal metaplasia. This isn't just standard inflammation. It's a maladaptive survival response where the stomach lining, subjected to chronic irritation, literally reaches a structural breaking point.
The gastric cells are fundamentally designed to secrete acid and enzymes, but they lose their ability to function in that hostile environment. In a desperate attempt to survive, they change their phenotype to mimic intestinal tissue.
They forget their primary function. This loss of identity is the ultimate precursor state, signaling that the protective barrier of the stomach has failed.
Once that metaplastic state is established, the data outlines a perfect storm hypothesis. The progression isn't triggered by a single factor, but the simultaneous failure of DNA repair, immune clearance, and a massive breach of the microbial ecosystem.
Isolating the genetic component first, the focus is heavily on the ARID1A gene. In a healthy, functioning cell, ARID1A acts as the primary quality control inspector, constantly monitoring the integrity of the genome during replication.
If a cell sustains damage, ARID1A initiates apoptosis. It forces a programmed self-destruction to prevent the propagation of errors. But in this metaplastic tissue we're discussing, this inspector is compromised.
When ARID1A is damaged or mutated, that self-destruct sequence is disabled entirely. Cells that have accumulated significant DNA errors are permitted to survive, lingering in the gastric lining and accumulating further mutations over the years.
We have to look at what causes that initial damage to ARID1A in the first place. The source material points to a highly specific fingerprint of damage found in precancerous tissue, which is the exact molecular signature of oxidative stress.
Unstable oxygen molecules or reactive oxygen species possess an unpaired electron. To stabilize themselves, they aggressively steal electrons from adjacent cellular structures, physically breaking the DNA strands in the process.
Metabolic dysfunction and environmental toxins are the primary drivers here, with smoking identified as a massive accelerant because it creates a direct influx of those reactive species into the tissue.
Internal metabolic dysfunction is equally destructive. When the cellular power plants, the mitochondria, are operating inefficiently, they leak electrons, creating this endogenous oxidative stress that constantly bombards the gastric tissue from the inside out.
This leads directly into the immune system failure, specifically clonal hematopoiesis, which explains why your body fails to identify and remove these mutated stomach cells.
As we age, blood stem cells in the bone marrow accumulate somatic mutations. The research uses the analogy of weeds taking over a garden. These mutated stem cells begin to dominate the marrow, producing functionally impaired, dysregulated immune cells.
The immune system becomes staffed by senescent cells that lack the sensory acuity to detect abnormal surface markers on a metaplastic cell.
They are biologically blind to the threat. This blindness allows the ARID1A deficient cells to proliferate unchecked. And this internal collapse creates a highly vulnerable environment for external invasion, which the research calls oral systemic translocation.
The presence of Streptococcus and other oral commensal bacteria living inside stomach tissue is a definitive sign of catastrophic ecosystem collapse. The human stomach is designed to be a biological sterilization chamber.
The gastric acid should maintain a pH low enough to completely destroy the cellular membranes of almost all ingested microbes. Finding oral bacteria thriving there implies the acid barrier has fundamentally breached.
The analogy provided in the research is finding ocean fish swimming in a freshwater lake. It's a biological impossibility in a healthy system.
Because the proton pumps in the stomach lining are no longer maintaining acidity, likely due to the atrophy from that intestinal metaplasia we talked about.
Yeah.
And these oral bacteria actively drive the pathology once they colonize the wounded tissue.
They stimulate an inflammatory response, but because the immune system is senescent, the bacteria survive. The chronic inflammation generates more reactive oxygen species, causing more DNA damage.
Which further degrades the tissue, allowing even more bacteria to colonize. It's a relentless feedback loop of destruction that also presents a synergistic toxicity, with H. pylori heavily amplifying its pathogenic potential.
Because these are biological processes, the sources suggest they are entirely reversible. The protocol for interruption begins with the oral cavity, aiming to prevent bacterial migration by drastically reducing the oral load.
Rigorous adherence to mechanical hygiene is mandatory. Brushing must be performed for 2 full minutes twice daily, utilizing a soft bristle brush angled exactly at 45 degrees toward the gum line.
Brushing flat against the enamel entirely misses the gingival sulcus, the shallow crevice between the tooth and the gum tissue where these anaerobic bacteria hide and multiply.
The bristles have to penetrate that sulcus to effectively disrupt the biofilm. Sequencing is also critical here. The absolute instruction is to floss before brushing, particularly in the evening.
Flossing physically dislodges the interdental plaque, moving it to an exposed surface so the subsequent brushing can sweep it out of the mouth. Reversing that order leaves the loosened bacteria to just settle back into the oral cavity.
Any sign of gingival bleeding must be viewed as a critical warning. Bleeding gums indicate active ulceration and a wide-open barrier between the oral microbiome and your systemic circulation.
Managing oxidative stress is the next metabolic defense. The source material warns against chronic carbohydrate restriction, detailing how it can induce reductive stress.
If carbohydrates are restricted too severely for extended periods, the flow of electrons through the mitochondrial electron transport chain stalls. This backlog of electrons creates reductive stress, forcing the mitochondria to release reactive oxygen species.
To maintain efficient energy production and minimize that mitochondrial sputtering, the recommendation is to maintain an adequate intake of carbohydrates, approximately 250 grams daily.
Alongside the fuel source, we have to address the structural integrity of the mitochondria. The research aggressively targets linoleic acid, found heavily in industrial seed oils, as a primary driver of structural cellular failure.
The structural issue centers entirely on cardiolipin, a highly specialized fat in the inner mitochondrial membrane that acts as the physical insulation for the electron transport chain.
When your diet is high in linoleic acid from oils like soybean, corn, or safflower, this highly oxidizable fat is actively incorporated into the cardiolipin molecule, making the entire mitochondrial membrane incredibly fragile.
It causes the cellular equivalent of a short circuit. The resulting electron leaks generate massive amounts of oxidative stress from within the mitochondria, directly damaging the DNA.
To prevent this structural breakdown, linoleic acid intake must be kept strictly under 5 grams per day, pushing toward an ideal target of 2 grams. This requires completely replacing industrial seed oils with stable saturated fats like tallow, ghee, and grass-fed butter.
The final component of this protocol involves synchronizing these biological repair systems with your circadian rhythm. The immune system's ability to patrol the stomach lining and repair DNA peaks strictly between 10 p.m. and 6 a.m.
If the body is metabolically active or awake during this evolutionary repair window, resources are diverted away from cellular regeneration. This requires consistent bed and wake times within a 30-minute window to stabilize the body's master clock.
The primary signal for setting this clock is exposure to 10 to 15 minutes of outdoor sunlight within 1 hour of waking. The light must strike the retina directly, meaning sunglasses are entirely counterproductive here.
Setting that morning clock dictates the evening release of melatonin, which functions as a potent antioxidant to clear the oxidative stress accumulated throughout the day.
This is exactly why alcohol consumption is explicitly contraindicated in this framework. It suppresses melatonin production, undermines mitochondrial efficiency, and heavily impairs gut immune signaling.
We really have to redefine early detection based on these cellular mechanisms. We must look for the downstream systemic effects of failure, rather than just waiting for localized pain.
Unexplained anemia indicating mucosal damage, sudden shifts in oral health, like spontaneous gum bleeding, and persistent fatigue signaling the mitochondrial dysfunction that drives oxidative stress.
By stabilizing mitochondrial structure, fueling the system properly to prevent reductive stress, and rigorously defending the oral barrier, you can interrupt this biological wear and tear before it ever progresses to a severe pathology.
Thank you for listening to Dr. Mercola's Cellular Wisdom. See you in the next episode.
Looking for trusted health wisdom you can hold in your hands? Discover the life-changing books of Dr. Mercola at joyhousepublishing.com. These titles bring decades of natural health research into practical steps for better energy, stronger immunity, and clearer thinking. Take charge of your health with guidance rooted in science and experience. Visit joyhousepublishing.com now and claim your bonuses while they are available.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.